Hello friends, welcome to our channel Knowledge Amplifier. So in this particular video, I am going to discuss how we can implement random forest classifier in MATLAB. Okay, in my upcoming videos, I will be discussing random forest regressor too. So here I have taken one interesting dataset which has information about students' study time and repetition time for a topic, and based on that, what is the knowledge level for a student we have to predict. Okay, low or high. So obviously this is going to be a correct classification problem, right? And you can understand that this is one categorical data, so we need to encode this because machine cannot understand low, high, these values, right? So we can map either high to 1, low to 0, or reverse way, whatever you want. And the point to be noted, as random forest internally implements many decision tree, and decision tree model is not a distance based algorithm, that's why we don't require to apply feature scaling. Okay, because feature scaling is required only for distance based algorithm. This is point number one. Then null value handling also decision tree can do by its own, right? I hope you know these important advantages of decision tree which I have already discussed. So let's directly go to the code. So CLC clear all closure warning of as is generally right, then data equal to read table study data.csv. The data I have taken in my current directory which is available here, that's why I no need to write the whole path. But if you are taking from some other directory, you need to specify the whole path here. Okay, that is path name as well as the file name. So now let's check our data. If we write data, we will be getting our data. The column names are like this, it came. All right, so importing data is done. Then what is the next step? We can check something like sum of is missing data. So see, 0, that means no null value present. Now next step, what we can do, we can handle this knowledge level. Okay, because categorical data handling we must have to do, else apart from that outlier removal no need to do, because decision tree is not, the decision tree classifiers are not affected by outliers, and no feature scaling also required. So if you are applying decision tree, this kind of data pre-processing stage becomes very much simple, because it has its own advantage and it can handle outliers, then feature scaling by its own. Okay, right. Then what I am doing here, k equal to high low, I am creating one array which is storing the distinct types which I want to encode. I want to encode high to 1, low to 0. And then what I am doing, I am applying this particular piece of code which after execution in the number variable will put 1 if that is in this particular column high is present, and in the number variable it will put 0 if low is present, right? Already discussed the explanation of the code in the feature scaling part, sorry, in the categorical data handling part, right? Then what we are doing, we are creating one new column, category encode to number. We are assigning the number which we got after encoding, and we are dropping knowledge level because it is not required. Okay, so let me just run this particular part and show you the data after handling the categorical variable. So new column came, category encoded, which is 1 when the particular value is high, that is student coming under high category, knowledge level of the student coming under high category, else that is 0, that is low. Okay, right? Then what we are doing, generally for cross validation, here we are doing HoldOut method. 30% we are keeping for testing the purpose. We are extracting the index, and those index which are not coming under this will be training data. So we are complementing the index logical data, and those rows we are taking and all columns, and for testing purpose we are taking the indexes which we are getting from cv.test and taking all the columns, right? So okay, let me run this particular part. So now train and test splitting also done. Here you can check data train. This is my training data. Okay, 181 rows, 3 columns, and data test. This is my test data, which is having 77 rows, 3 columns. Okay, so this is nearly 30% of our actual total data set, right? If you check total size of data, you'll be getting 258 rows. So 258 cross 30 by 100, you'll be getting 77.4. So test data containing 77 rows. Okay, right? Then for test data, the label column, that is the categorical output, okay, that is this particular one, category encode which we have got, this is not required because this we want to predict, right? So what we will do, we are creating one testing data where we are taking all the rows, but columns we are taking from start to end -1, that is we are ignoring the last column because this is not required for testing. We'll predict it, then we'll cross-validate it using this last one. Okay, right? I hope up to this clear. Then what we are doing here, see carefully, model equal to fitctree dataTrain category encoded. So we are passing our data which we kept for training, and which column of my training data is basically our output categorical feature that we need to specify inside quotation. Okay, then we are using predict function for prediction purpose, where my first argument will be the model which is trained using fitctree, that is fit classification tree, this decision tree classifier, and then testing data which we are passing apart from the known labels for testing data. Okay, then here we are calculating the accuracy. So accuracy calculation is very simple. How? So prediction output and the test data actual labels, if they are same, then that is correct prediction. So we are computing using equal to and then sum, and then taking multiplied by 100 for percentage, dividing by total number of rows present in my data. Okay, right? So let's check the accuracy what we are getting using only one single classification tree, that is 94%. Okay, and this last piece of code is for visualization, as I generally do. Let me just run this. Okay, Control A and evaluate selection. Code will be posted in the description box, no need to worry. So here, this is my plot. Okay, right? So what I will do, I will save, I will just take a snip of this so that we can compare with our regression tree also. Okay, let me take snip of whole part. So now 94% is our accuracy for classification tree, one single classification tree, and this is our decision surface. Almost all are predicted correctly apart from this one. Okay, no problem. Now what we are doing, we are applying the same code, same logic, just the model training part is different. See how I have written fitensemble. So this random forest is an ensemble technique, so you have to specify fitensemble. Then dataTrain, as we have passed, what is the output feature, we are passing that, okay, as the string. Then random forest is a bagging technique, right? So I am passing bag. Then how many decision trees will be found under random forest? 100 trees. Okay, and tree, so ensemble technique you can create using KNN also, using discriminant analysis also, using tree also, right? So different methods are there. So I am specifying that ensemble will be created, majority voting will be created based on tree, that is decision tree will be implemented, 100 decision tree, and then majority voting it will be considering for output. And type is classification. So for regression problem, just here you need to change from classification to regression. Rest of the part code is completely same. Now let's run the whole code and observe the accuracy and difference. It is not necessary that you will be obviously getting higher accuracy than a single decision tree, but generally we get that. Like see here we are getting 97.4026% accuracy, whereas actually while applying our single decision tree we got 94%, right? And if you take the decision surface, the important difference you can understand. See here, this is our decision surface, decision boundary, whatever you say, for random forest, and this is for one single tree, and here 100 trees are implemented. That's why if you see that there are much changes present in this decision surface, whereas here there is not that much change. This particular random forest is trying to capture the pattern of our data as much as possible. That's why if I just make it bigger, you can see that here 3 data points of different class coming. That's why it is going inside and then again coming outside like that. That is, it is trying to capture the maximum amount of pattern, because 100 decision trees implemented, extremely powerful algorithm, right? So this is the beauty of random forest. Most of the time you will be getting higher accuracy and this much beautiful visualization where most of the pattern it is trying to capture. Like here one single point is coming, kind of obviously overfitting is happening if you don't tune your model properly using hyperparameter tuning. You can do that, no problem. So this is how you can simply implement random forest. Just you need to remember fitensemble is the code. The documentation link I'll be providing in the description box. You can go and explore, and remember the parameters which you have to give input. First one is training data, then in training data which column should be output parameter, then random forest is bagging, so you have to give bag, then how many internally how many small base algorithm you want to implement, like here 100 I have specified. Then the small algorithm should be decision tree for random forest, so I have specified tree, and this is classification problem, so I am specifying type classification, right? So I hope you have understood this. Code and data will be posted in the description box or in the comment section. If you want, you can go and check there. This is all for this video. Thank you.